Hi guys, welcome to my first video course on functions. This course is designed to be a pre-course for calculus. It's going to be a nice little primer, and I'm going to cover the topics that I think are the most important before we study calculus. Okay, so the first thing we need to study before we start with our calculus is functions. Okay, so what are functions? So what are functions? A function is basically anything that takes an input, and with that input it gives you an output. Okay? So a function just takes an input and gives you an output. Let me show you a graphical representation of what a function is. So a graphical representation of a function is going to be something like this. Okay, so we're going to have an input, and to this input, we're going to put it into a box, and we're going to get an output. And this output is just something. And this little box is called a function. Okay? So basically, that's all a function is. It takes an input and it gives you an output. Now, in math, our inputs are assumed to be all from a set called the real numbers. Okay, so what are real numbers? This is the notation for real numbers, and real numbers consist of a union of other sets. Okay, so a set of integers, natural numbers, rational numbers, irrational numbers, and really big numbers. You get it. You get the idea. They're all they're all part of the real numbers. Okay? So for our functions, our input is going to be real numbers. Okay? So that's that. Now we're going to cover an expression that you're going to see quite often when you start working with functions. That expression is going to be something that looks like this. Y is equal to f of x. I remember when I started learning functions, this expression didn't always make 100% sense to me. So what this means is y is a function of x. Okay? And graphically, we can represent this by x goes to a box, and this box returns y. And this box, we can label it as f, like the f from here. Okay? Like the f from here. So that's basically all what a function is. So this is a working definition of a function. It's not the exact definition or the formal definition of a function. We'll get to that once we cover a little bit more material. Okay, so before we learn about that, we have to cover a few more terms, and we're going to call these two terms that we're going to be covering the domain and the domain and the range. All right, so the domain and the range. Domain and the range. Now, what is the domain? The domain is all possible values that x can take. The next thing we're going to ask is, what is the range? The range is all possible values that f of x can take. Okay, this is just definitions. And I'm going to give you an example to make this much clearer, okay? So let's go on to the example. So let me move this here. We'll just leave that in for us, and we'll go with our first example. Our first example is going to be a very common function. It's a parabolic function, and we'll call it f of x is equal to x squared. So what is the domain of this function? What is the domain of this function? What can it be? Well, it's anything from minus infinity to positive infinity. Why is it anything between minus infinity to positive infinity? Because you could put in any value of x here, and x squared can take it. Minus 1, you have a result. Minus 3, you have a result. 2, you have a result. 4, you have a result. So for any value of inside minus infinity to infinity, x will accept this value. So the domain is all of minus infinity to infinity. Now, what is the range of the above function? Well, let's see. Can minus 3 be part of the range? No, it can't, right? Because x squared is a function that's always positive. So minus 3 cannot be part of the range. The lowest value that this can take is 0. And the highest value it could take is infinity, right? There's no, and actually I shouldn't be writing them like this. These should be, you can't really, when you're dealing with infinities, you have to use the smooth brackets. You can't use the square ones. Sorry about that. So it's, yeah, so it goes from 0 to infinity. Okay? So the range is from 0 to infinity. And just to see graphically what this graph looks like, it's something like this, right? So if I'm drawing it, sorry for my drawing, it looks like something like this. And see, you could see there's no negative values that f of x can take, right? All the values, but it could take any value here. The values here can, on the x-axis, they could be any value, but on the y-axis or the f of x-axis, you cannot. You can only have positive values. So that's why the domain is minus infinity to infinity, and the range is 0 to infinity. Okay, so that's cool. So let me ask you guys a question. So give me the domain of range of the following function. You could put them down in the comments below. So f of x is equal to x squared plus 1. If you could put it in the comment below, the domain and the range, it'll let me know that you guys, my explanations are somewhat clear and you're understanding them. Okay, so that's that. Now let's look at a slightly more involved example. Okay guys, so let's look at a slightly more involved example, okay? I just brought the definition down again just to make life easier, and this is going to be the new example that we're going to look at, okay? So the example is going to be f of x is equal to 1 minus x squared, okay? So now we want to try to find the domain and the range of this function. Okay, so let's start by drawing how the square root function looks like. I think it'll help us understand how to solve this problem, okay? So the square root function looks like something like this, okay? So let me just draw it very rough here. The square root function starts at 0 and then it starts to build up slowly like this. Okay, I'm not drawing it to scale, but it's a smoother curve, but it's going to slowly build up like this. Okay, so what can we see? The value of the square root function has to always be greater than or equal to 0, the x value. Okay, so every argument to the square root function has to be greater than or equal to 0. So let's start by writing that down. So 1 minus x squared has to be greater than or equal to 0. Let's write this a different way. So we could write it as 1 has to be greater than or equal to 0. Or, sorry, not greater than or equal to 0. Let me get rid of that. 1 has to be greater than or equal to x squared. Okay? And this we could reformulate to x squared is less than or equal to 1. Okay, so where can we go from here? Well, we can go from here to x has to be less than or equal to 1 or greater than or equal to minus 1. Why can we do this? Because for any value of x between minus 1 to 1, we'll respect this equation, right? So if we put the value of minus 1 there, we're going to get 1, and 1 is less than or equal to 1. Same thing if we put 1 there. 1 squared is 1, 1 is less than or equal to 1. And any number between minus 1 to 1 is, if you square it, it becomes positive and smaller than 1. So it's always going to respect that, right? So let's take an example. Minus a half. Minus and a half squared is a quarter, and a quarter is less than or equal to 1. Minus a quarter squared is an eighth, and an eighth is less than or equal to 1. And same thing, and so same thing. So any number that's less than 1 is going to be less than 1 when you square it. So we could say that x travels between minus 1 to 1. And by doing this, we just figured out what the range is, right? Because the domain is all possible values that x can take. So we know that the domain of this function is between minus 1 to 1. Okay, now let's start looking at what the range can be. Okay, so what is the minimum value that this square root function can take? The square root function, the minimum value that can take is 0, right? 0 is the minimum value that it can be ranged. Now let's see if we have an x in our domain that can give us a 0. Can you guys think of one? We actually have 2, right? If we put 1 in here, 1 squared is going to be 1 minus 1, it's going to be 0. And if we put minus 1 in here, minus 1 squared is 1, 1 minus 1 is 0. So 0, the smallest possible value for a square root function, is in there. So that can be an argument to the square root function is in there. So we could add that to the range. Okay, now let's look at this. The square root function was going to keep on growing infinitely, right? In the positive direction. No matter what positive number you put in, you could square root it. So we don't have an upper bound in the real square root function, but we might have an upper bound here because we are restricting our domain to be between minus 1 and 1. So let's see what's the maximum value that we can put here. So the maximum value that we can put from our range to get here is 0, right? Because 1 minus x squared when x is 0 is 1 minus 0, which is 1. Any number between this range that you put in here is going to be a positive number, right? Because minus 1, square it. If you put 1 minus a half, you square it, you're going to get a quarter. 1 minus a quarter is going to be less than 1. You put another number here, any number, any negative or positive number here, between the ranges minus 1 and 1, it's going to turn into a positive number, and 1 minus that positive number is going to be less than 1. So the maximum value that you can get is when x is equal to 0, right? So because of that, the range, the upper bound for the range is 1. So there we have it, guys. We figured out the domain and the range for this function. Okay? So that's it for my first video on functions. What I'm going to do is I'm going to do another video where I'm going to go over the formal definition of the function and also the vertical line test. So look out for the next video, guys. If you have any questions or if you have any comments or critiques even, please put them down in the comment section below and I'm going to read them and I'm going to get back to you. Thank you very much, guys. Bye.